Hello, our video today is going to kind of bring you back a little bit. This video is just going to be on a review of factoring and all the different ways that you can factor. So we're going to start off with the basics. The first thing that you should always do when factoring is check to see if there is a GCF, a greatest common factor. So do they share anything? If I look at the first one, I've got a 6 and a 2, which means I can pull out a factor of a 2. This is x squared, this is x, so I can actually pull out a 2x. And remember, when you're pulling out that GCF, you are dividing it out. So that's 6 divided by 2, which gives you 3. You had x squared, and you're pulling out one of those x's, so then you have an x left, minus 2 divided by 2 is 1, x, we took that out. Now sometimes we make the mistake of leaving that piece empty. We can't leave it empty. Something divided by itself is 1, not 0. So this would be my answer when I pull out the GCF. In number 2, I look at all three terms. We've got a 3, a 6, and a 9, so I can pull out a 3. When I look here, I've got an x squared, an x, and no x's. So that's actually the only thing that I can pull out. And remember, I divide. 6 divided by 3 is going to be 2x. 9 divided by 3 is 3. We would check to see if we can factor more, but this trinomial member means 3 terms, is not factorable, so we're going to stop there. When we look at number 3, x cubed, 2x squared, 5x. So there's no number, because remember that's going to be a coefficient of a 1. There's 3 x's, 2 x's, 1x, so I can pull out a factor of an x. So if I have x cubed and I take out 1, I've got x squared left, minus 2, we had x squared, we took one of those x's out, so we've got 1 left, and then our 5x, all we're left with our 5. Again, for this particular example, we have our trinomial. Normally we would continue factoring, but that one is not factorable, so we go ahead and stop there. The next kind of factoring is the difference of two squares. So when you're looking and you're thinking about this, the words difference means that we have subtraction. If you don't have subtraction, it's not the difference of 2. That's why we only have 2 terms in each of this. And squares, that's going to be perfect squares. If they're not perfect squares, then you can't use the difference of 2 squares. So we look. We have difference, we've got subtraction, we've got 2 terms, and they are each perfect squares. So when we go to factor this, we get our parentheses all set up. We take the square root. The square root of x squared, so what number did I multiply by itself to get x squared? Well, that's x. Square root of 4, what number did I multiply by itself to get 4? That's 2. And then one's a positive, one's a negative. It doesn't matter which one you put first, whether you put positive or negative first. That is our answer. So if I go to number 5, the difference of 2 squares, we've got subtraction, we've got 2 terms. 36x squared is a perfect square. 25 is a perfect square. So we get this all set up for us. The square root of 36x squared is 6x, so that's our first term. The square root of 25 is 5. And then we just make one a positive, one a negative, and we are done there. Go to number 6, subtraction. Oh, we don't have subtraction. We cannot use the difference of 2 squares, but we do want to be careful here because we kind of got caught up. The first step of factoring is always GCF, so maybe that'll fix it. We look at our 2 terms. I pull out a 4. Still doesn't help me because I don't have subtraction. It's not the difference of 2 squares. So I was able to factor slightly, but the only thing that I could do was a GCF. So that's going to bring us next to our regular factoring. And regular factoring is when you have those 3 terms and your A value is 1. When you are doing regular factoring with a trinomial, 3 terms, you are looking for 2 numbers that multiply the outside and add to the middle. We are always going to start with the multiplier. So think about all the different ways you can multiply to 9. 9 is not too bad because we have 1 and 9, 3 and 3. There's no other 2 numbers that multiply to 9. So now we want to manipulate those numbers using positives and negatives so that they multiply to a -9, but also add to a +8. So if I'm multiplying to a negative, that means I need to have one positive and one negative. Because if I had two positives, it would be a positive. If I had two negatives, it would be a positive. So I need one positive, one negative. Now when I add those numbers together, they need to add to a positive. That means the larger of the two numbers needs to be positive. So I look to see of those options which one is separated by 8, and that is 1 and 9. So it's a +9 and a -1. You're done there. Same thing for our next one. We're multiplying to the outside, adding to the middle. If you struggle with regular factoring, remember always think about how can you multiply to get 35. 1 and 35 and 7 and 5. I don't think I'm missing any there. So as we go to set it up, we think about our pieces. We are multiplying to a negative again, so we need one positive, one negative. They are adding to a -2. Since the sum is negative, that means that the larger number has to be negative. So of our options, we look to see which one is separated by 2, and that's 7 and 5. So the 7 has to be negative, and the 5 needs to be positive, because 5 times a -7, -35, 5 minus 7, -2. Number 9. Now when we go to number 9, I said the a value had to be equal to 1, and I look here and my a value is 2. And that's because sometimes regular factoring is hidden by a GCF. So don't automatically jump into Batman factoring, which is what we're going to do next. Always check for a GCF first. So I pull out that GCF of a 2, which just means, again, I'm dividing each of those terms by 2. Now that I have that pulled out, we're multiplying the outside, adding to the middle. So again, we think about the multipliers of 30, 1 and 30, 2 and 15, 6 and 5. Now we want to use those numbers. Oh, I missed one. 3 and 10, so that they add to 13. Now I'm multiplying to a positive, which means they either both have to be positive or they both have to be negative. Because my sum is positive, that means they both have to be positive. I look at which ones add to 13. That's 3 and 10. Don't drop your GCF though. That 2 out front is still part of the answer. Number 10, again, we are multiplying to the outside and adding to the middle. So if I think about multiplying to a +4 and adding to a +4, that's 2 and 2. Now what I want to do is I want to take this one step further. This is a +2, this is a +2. Those are the same quantities. So you do have to keep going. You can't stop there. I'm going to rewrite this as x + 2 quantity squared. I have that quantity of x + 2 twice. Now please do not confuse this with what we did up here. In number 4, this is an x + 2 and this is an x - 2. Sometimes people make the mistake of trying to put that into a quantity squared. It's only quantity squared if it's the exact same piece twice. All right, number 11, we look for that GCF, and I can not only pull out a 3, I can pull out an x from each of them. As I divide that out, I've got x squared minus 10x plus 25. We are multiplying to the outside and adding to the middle. Now I'm multiplying to a positive and adding to a negative. That means that each of them has to be negative, and I went ahead and yes, it's 5 and 5. A -5 times a -5 is a +25. A -5 plus a -5 is a -10. So we see that same thing where I have the exact same quantity twice. So I'm going to go one step further and write that as x - 5 quantity squared. And yes, you do have to go that one step further. All right, so our last kind of factoring review here is Batman. And Batman is what you get when the a value is not equal to 1. So we had a couple examples in regular factoring where it didn't equal 1, but when we pulled the GCF out, it ended up being 1 in the end. This is after the GCF. It's still not equal to 1. So I look 6, 13, 5. None of those have a GCF that I can pull out. So Batman factoring is you multiply the first term and the last term. That gives me a negative 30. X squared. We pull down the first term. We pull down the last term. This might be one that you want to watch first, pause it, rewind, and then write it the second time. And then what we want to do is we want to find two numbers that are going to multiply here and add here. So two numbers that multiply to a negative 30x squared and add to a positive 13. So if I'm multiplying to a negative, that means I need one positive and one negative. If I'm adding to a positive 13, that means the larger number has to be positive. So this happens to be a positive 15x and a negative 2x, because 15 times negative 2 is a negative 30. 15 minus 2 is that positive 13. Then what you're going to do is you are going to group the first two. You're going to group the second two. From the first two, you are going to pull out the GCF. So between a 6 and a 5, I can pull out a 3. X squared and x, I can pull out an x. That leaves me with 2x plus 5. In the second group, there is no GCF, but this needs to be a positive 1, so I'm going to pull out a negative 1. If there is no GCF at all, then you pull out a positive 1. So that becomes a positive 2x, and that becomes a positive 5. Now when you look here, this is where you check your work. These two pieces have to be exactly the same. If those are not exactly the same, then you did Batman wrong, or it's not factorable. So to get this all put together, we take the two GCFs that we pulled out. Those come together for the first term. Those repeated pieces are the second term. And there's your Batman factoring. Now I'm going to go back to this step right here. There is no rhyme or reason of which one has to come first. So I'm going to show you that it honestly doesn't matter. So if I'm back at this step, and let's say I did the negative 2x and then the positive 15x minus 5, I do the exact same thing. We group the first two, we group the second two, we pull out the GCF, which is different this time, leaving us with 3x minus 1. We pull out the GCF of 5, which is 3x minus 1. The two GCFs give me the 2x plus 5. And then that same piece on the inside gives us the 3x minus 1. So depending on which of those numbers you put first, it's just going to kind of make your next step inverted. But you're going to still end up with those exact same two factors. All right, with number 13, what I want you to do is I want you to press pause, and I want you to see if you can replicate those steps that we just did for Batman factoring on number 12. Push pause when you are all ready, set to go. Go ahead and push play and see how you did. All right, I hope that some of you guys used the same numbers I did and some of you guys switched them just so that you can reinforce the fact that they are going to be the same. Now, I don't think that I talked about already, I skipped over of why we call this the Batman method. And the reason why we call it the Batman method is because when all is said and done, after you bring down these numbers, you kind of have something looking like Batman wings here. Anyway, so we multiplied those two together to get that negative 84x squared, brought down the first term, brought down the last term. We're multiplying to negative 84 and adding to a negative 25. So that's a negative 28 and a positive 3. I pulled out each of my GCFs. Remember we talked about in number 12. 3x minus 7, there was no GCF. So I do have to pull something out, so I pull out a positive 1. The two GCFs become one term. what was left becomes the second one. Okay, and hopefully that brought back some of your memories of factoring, kind of sharpened up your skills. We are all done.